So again, this is going on page 5. You are graphing y equals 3 sine 2 x minus pi over 2. Okay? All right, so looking at this, what does this 3 mean right here? What does this 3 mean? You multiply your y's by 3. That 3 is called the what? It's called the amplitude. Yes, we're going to multiply all of our y's by 3. Anytime there's a number in front of your sine or cosine, it's multiplication. So I'm going to have, what's the numbers?
0, 3, 0.
Okay, easy enough. Now here, the 2. The 2 affects our what? It affects our x's. How so? Times by 1/2. That 1/2 affects your period. What is going to be the period of this function? What's the formula for period? Over absolute value of b. b is 2. So what's 2 pi over 2? Pi. So our period is pi. That means we're going to have one complete cycle in pi radians. Okay, so we're going to multiply by 1/2, and then we're going to do what? So our x's. And pi over 2 represents our phase shift. So let me thin out this pen a little bit. 0 times 1/2.
0.
Plus pi over 2. Pi over 2 times 1/2. Add pi over 2. Multiply by 1/2. Add pi over 2. Multiply by 1/2. Add pi over 2. And remember, guys, that all these are equally spaced out, so there should be a pattern, okay? You got pi over 2, 3 pi over 4, pi, 5 pi over 4. It's basically hitting like an axis in the middle, axis in the middle, axis in the middle. So when you do 2 pi times 1/2, you get, and if you add pi over 2, you hit. And there's what you're plotting. That's what you're graphing. Did you guys get these numbers?
Yes.
Okay, so pi over 2, 0, 3 pi over 4, which is half away, 3 pi.
Oh, that's just your period. That shows you how.
Not too bad. Questions?
Okay, you said the 3 is the amplitude?
Yes. So remember, amplitude is basically the height.
There isn't a number in front of it.
Then that means it's going to automatically be
A 1?
a 1, which means that it's the basic or normal height up from 1, positive 1 to 1. And remember, the amplitude is basically from some middle line that's supposed to be dotted and just starts here together to the maximum or the minimum. Okay? All right. So let's put everything together, everything that we've been doing. Okay? So take a look at this type of example. It's going to be on page 6. We're going to have 2 of these on page 6, and they are going to be hand-drawn. Okay? Okay? These are going to be hand-drawn. We're going to state the amplitude, period, frequency, and phase shift of each function.
What is this title on?
It's just an example just to go along with what we've been doing. And then we're going to grab one period of each function. Now, do you guys want to do this one together, or do you want to do it on your own?
Together.
Together? Okay, we'll do this one together, and then the next two are going to be on your own.
I have a question.
Yes.
Okay, so let's say the period is just pi.
Yes.
You said the frequency, like the period, you flip it. So would it just be like 1 over pi or something?
Yes. And it's not just 4 pi, it's for any of them. The frequency is always the reciprocal of the period. All right, so we're doing this one together. Let's run through the information first. What is the we'll call them folks. What is the amplitude of this function, Monica? It is 1. Yes, the period of this function, Caleb.
Is that pi over 4?
How'd you get that?
I just took C, but I forget how to do it.
Remember, your period is the formula 2 pi over the absolute value of b. So, Caleb, what's b in this problem?
B would be x over 2, or just 1/2.
It'd be 1/2.
So
Okay.
it's just
Careful. Whenever you have a fraction within a fraction, you need to keep, change, flip. Remember, x over 2 is the same thing as saying 1/2 x, so don't let that throw you off. Frequency. Anna, what's our frequency?
1 over 4 pi.
Very good. 1 over 4 pi. Yes, you just flip your period, and I'm writing too big, so I'm about to go into my graph area. Now the phase shift. Be careful with the phase shift. I'll take a volunteer on this one who thinks they have the phase shift. Any volunteers?
Oh, no.
Ada.
negative 1/2 over pi over 4.
Negative 1/2 over pi over 4. Very close.
No. Oh, negative pi over 4 over 1/2.
That's right. Negative pi over 4 over 1/2. Negative c over b. Sorry, like I said, my pen's been sticking together. So we'll do negative c divided by b, which can be simplified.
Negative pi over 2.
It's going to be negative, pi over 2. Keep, change, flip, and that is going to be a negative pi over 2. It's our phase shift. If you notice, the b is on the inside, so this is when we have to use the formula.
How do you find efficiency?
It's the reciprocal of the period, so you split the period. Questions on all the goods? So this problem is not just C, because if you see, as you can see from the equation, B is on the inside. Okay, there's not a number out front to represent your B. Your B is already inside, right beside your X. So that's when you have to do the formula. Let's make our table. Let's make our table for this stuff. I'm going to a new page because I do not have the space to do a table and the graph. So, what's happening to my x's? I have to do x times 1 over b. So I'm going to multiply it by 2. I'm going to multiply it by 2. And then I'm going to add or subtract my phase shift. What's my phase shift? Power 2. To my y's, I'm going to multiply it by, that's where our amplitude was 1, but then I'm going to add 1. So I'm going to multiply by 1. So add 1. Take 5. The y's is the sine, correct, or was it cosine? It's cosine, so y start with 1 or 0? 1. Be very careful. And remember, these values are coming just from our unit circle. So I'm going to multiply by 2, subtract pi over 2. Multiply by 2, subtract pi over 2. Multiply by 2, and you get where I'm going with this. And if you catch it, you can see a pattern. I got pi over 2, 3 pi over 2, 5 pi over 2, so the next one should be 7 pi over 2. And that's exactly what you get if you did, like denominators, blah, blah, blah. Times 1, add 1. Times 1, add 1. Times 1, add 1. And there's your table.
Where do you get the 1? You're adding 1 to y. Where should you get that?
Well, I'm doing this middle line right here is just the multiplying by 1 part.
Yeah.
And then the adding 1 came from your D. Remember, whenever there's something on the outside, that affects your Y's.
Oh, yeah.
Can I say 7 pi?
Yes.
What's the correct scale of
Going by power 2 and 5. So power 2, 5, 3 power 2, 2, 5. You gotta get all the ones that are in the middle. But these should make your own scale. Yeah. So we're doing this one by hand. Let's see if I can remember everything. Negative power 2. No, not. So it's negative power 2, 2, power 2, 1.
Yes.
Thank you. 3 power 2, 0. 5 power 2, 1. And then 7 power 2.
Is there only going to be 2 on this page?
Yeah. There you go. There's your function. Graph of your function. Okay? So you're going to do the next two on your own. Same directions as before. Amplitude, period, frequency, phase shift, graph. This one's going to be on page 6. And then the other one is on the cosine flap of your foldable. Okay? Those are the two that you're going to do. I'm going to give you 10 minutes to do it. All right, so starting on page 11, I think it would be a good time than any to put the summary of everything that we basically just talked about. So your summary of your concepts that we have talked about when it comes down to graphing or looking at the graph of a trig function. So the graph of y equals a sine bx plus c plus d, and as well as for cosine, where a, of course, does not equal 0 and b does not equal 0 as well. We have the following conditions, okay? Remember, amplitude is the absolute value of A. Amplitude is the height of the wave, the sine or cosine wave, okay? The phase shift is, of course, negative C over B. Again, we're talking about this form where the B is on the inside. We find our period by doing 2 pi divided by the absolute value of B. Our vertical shift is D. Our frequency is the reciprocal of our period, or absolute value of B over 2 pi. And this last one, midline, which I hinted at, but I never actually sat and said, hey, this is the equation of the midline. The midline is exactly what it breaks down to be. It is the line that cuts the graph through the middle. Okay, it's always a horizontal line, hence why it's always y equals. And that line is always what the vertical shift is. Because when you move the graph up, you're moving everything, including that equilibrium line, aka the midline.
What happens
What happens if the what?
if the amplitude is negative?
If the amplitude is negative, then when you actually are identifying what the amplitude is, it's always the positive version of that number. That's why it's absolute value. But when you're graphing it, you always multiply your y's by a. So a is negative, that's what you're multiplying it by, the negative 2 or the negative 3. But the amplitude itself is always positive because it represents the height. You can't really have that. So we have basically taken the equation and graphing the function. Now what we're going to do is we're actually going to go the opposite direction. You're going to be given a graph, and you're going to have to write the equation yourself. Or you'll be given different pieces of information like the amplitude, like the phase shift, and you have to write the equation yourself. So basically we're going backwards now, okay? So we're going to start off with 3 examples that are like the word examples, okay? We are going to write a sine function given that the amplitude is 3.75, the period is pi over 2, and the phase shift is pi over 45. So you're changing that phase shift to a pi over 4. Now, To write an equation, of course you need to know the general form of an equation for a sine function. We know that it's y equals a sine bx plus c plus d. Okay, that's basically what we've been given. That's what we've been using to pull out all our information and use to graph it. Okay, so at this point, it's almost like a plug-in type thing, but you've got to be careful. Okay. Now, A represents our what? And don't we know what our amplitude is already? It's 3.75. So far, we're 1/4 of the way towards the correct answer. So we plug that in. Okay? Now, do not get it twisted. B does not represent your period. There's a formula that uses B to find your period. What's that formula? What's the formula for period? 2 pi over the absolute value of B. So if your period is the formula 2 pi over B, absolute value, okay, then we basically have to set up a little small equation. Since we know our period is pi over 2, we're going to plug that into this equation and use this equation to solve for B. Does everybody see that? We're not given the B, we're given the period, so it's like we have to go backwards. We have to set the period equal to 2 pi over B and find B. How do you solve this? Cross multiply. What's pi times B? What's 2 times 2 pi? So all we did was just cross multiply, set them equal to each other, and now what do we do to find B? What's 4 pi divided by pi? So B is 4. Does everybody see how that works? B is not your period. It's what you use to find your period. So if you're given your period, you have to set up an equation to find it. Yes? Now that is to your discretion, okay? Now this B, whether the B is on the inside or the B is on the outside, it's found the same way, okay? So finding B isn't the issue. When B is on the inside or outside, that's when it's the phase shift that really gets affected, okay? Since B is on the inside, C, just like B, does not represent the phase shift. It's a part of the formula that helps you find the phase shift. What's the formula for phase shift? So negative C over B equals your phase shift. Well, then we just figure out what B was? It's what? 4. And we know the phase shift is pi over 4. So what is C going to be? Negative pi. And you can get that the same way by cross multiplying 4 pi equals a negative 4C. Divide both sides by negative 4. And then that's how you get your C. So it really is the ones on the inside that you have to be careful about. B and C do not represent period or phase shift. They're used in the formula to help you find those things. What does D represent? Vertical shift. Do we have one? No. It's 0. Do we have to put it? No. If you did, you're not going to get counted off. So this is our final answer. There's the equation that represents this particular situation. But the one thing that I notice with students is that they forget that B is, like, they think B is the period. It's not. B is used to find the period. Just like C. C is used to find the phase shift. Okay? Let's look at the next example. Next 2 examples. The last 2 when it comes down to writing. How does it start? 3 cosine. Cosine function. Parentheses. What's B? Pi over 2. Okay, how'd you get that? cross multiply, that's going to be a 4 pi b equals a 2 pi. And when you divide by 4 pi, what happens to the pi's? They what? They cancel out. So it really is just 1/2. See that? 1/2 x. So then so if you did do pi over 2 for your b, it's going to affect your phase shift because you got to use b to find c. But hopefully you set pi over 3 equal to a negative c over 1/2. Now if you're like negative c over 1/2, that is a fraction within a fraction. Keep, change, flip. Technically that's the same thing as saying what? Negative c times 2. You can still cross multiply the way it is, just, you have 1/2 pi equals negative 3c. It'll be around the same thing. How do you solve for c? Cross multiply or divide by negative 2, either way. If you do divide, how does that simplify? Keep, change. When you flip negative 2, that turns into what? So what's c? Do we have a d? Questions? Any questions at all? Yes. The formula for C deals with your phase shift. Remember, phase shift is equal to negative c over b.
How do you keep change flip?
How do you keep change flip?
That's what I thought that's what you're supposed to do.
Well, that's what we did here to get the negative 2c. We kept the top and flipped the bottom. And then when we got here, we kept the top and flipped the bottom. Remember, 2 is the same thing as saying 2 over 1. So when you flip it,
Yeah.
and then you multiply straight across. Last one, we have y equals. Y equals sine. Because what's our amplitude? What's our A? 1. So it's just 1 sine, which is just sine. That's an S, not an 8. I was going down the line. It's what? It's x. Yep, because the period's 2 pi. If the period is 2 pi, and it has to equal 2 pi over b, well, the only number that could possibly be that is 1. So you put a 1x, put x. Okay, wait, hold on. Yes?
Since it says the reflection of the x-axis with the amplitude negative.
I was just like, is that? Yep, so just go, I'll just bring through it. But yes, there is a reflection of the y-axis, which means that the outside does need to be negative. We have a phase shift of 2 pi over 3. It'll be a minus 2 pi over 3. And a vertical shift of negative 1. We need to fix the negative. It does need to go in front of the x. Because when we flip over these y-axis, we're technically making our x's negative, correct? So that means our x needs to be negative. But that's not going to change the sign of our phase shift because it's always negative c over the absolute value would be. So let's change our sign there. Alright, so we're going to write a cosine equation for the following graph. Does everybody remember what regular cosine looks like? Looks like a bell. Like this. Okay? This one's a perfect example of a cosine function. Now, one thing I always like to do is I always like to try to find where the midline is. Where's the line that cuts the graph in half? It's right there at 0. If the midline doesn't change, then you already know that there is no vertical shift. Okay? If the midline's at 0, then that's what it is. Okay? That is your vertical shift. Your vertical shift is 0. So we already know one piece of information. We already know that D is 0. Now, from this midline, we can find the amplitude. The amplitude is the distance from that midline to a or a mid. What's this distance from this midline down? It is, the amplitude is actually going to be a positive 2. It's not a negative 2 because if you look, doesn't cosine start at the y-axis and then go down normally? Think about it, the original cosine goes like this. So if it starts there, then you know it's going to be a positive 2. Now, to find your B, B does deal with your period. The period is the length it takes to complete one full cycle. If I start here, how far do I go before I'm starting to repeat myself? So the period is 2 pi. Again, the length of time it takes to complete one full cycle. So if my period is 2 pi, what's the value of B? 1. So 1x. Now the phase shift. Listen carefully. For cosine, if cosine starts at a maximum on your y-axis, then there is no phase shift. I will say that again. For cosine, if a maximum occurs at your y-axis, there is no phase shift. And the reason why is because your normal cosine curve that starts at 0, 1, all that happened was it just got stretched. The maximum never moved from this point. It still is occurring at your y-axis. So if you need to make a note, do so. But for cosine, if the maximum is on your y-axis, and it doesn't matter where, name it 3, name it 5, but if the maximum is on your y-axis, there is no phase shift. And so if there's no phase shift, is there a C? No. So plus 0.
If it's on the y-axis, there's no phase shift?
Yes. And there's your equation. If I want to make it a little nicer, it'll be 2 cosine x. There could be a parenthesis around the x when there's not a phase shift or a b or anything like that. It can't be written without it. If you put it, that's fine. Questions on this? Let's write a sine graph next, okay? We're going to write a sine graph. Just like before, I want to find that midline. Where's the midline going to be? In 2. So this graph basically got moved up 2 units. So the midline's at 2, that means that which variable is going to be 2? The D. Let's find our A next. What's that distance from the midline to the maximum? You don't have to put 1, I'm just putting it because I have the spaces there. Everyone okay?
Yes.
Let's find B next. Remember, B deals with the period. What's the period of this function? How long does it take to complete a full cycle? Pi. So my period is pi. What would B have to be? What would B have to be? It would have to be Now for sine, your phase shift, it's different from cosine, okay? Normal sine crosses the y-axis where? Zero. It goes like this, doesn't it? Okay? Now if you look at this graph, doesn't it still kind of cross the y-axis at that point? The old school 0, 0? It just got moved up 2 units. Okay? So really and truly, is there a phase shift here? No, it just was a vertical shift moved up. So if there's no phase shift, what is C? So if I want to write a little cleaner, that'll be my equation. Everybody okay? Of a graph. The next one is half a graph, and we're going to write a sine and a cosine function. Okay? Now, the beauty about writing sines and cosine functions, A, B, and D are all the same. So whether you write a sine function or a cosine function, A, B, and D are all the same. So when you find it for one, you found it for the other. The only difference is your phase shift. That's the only difference. Depends on the equation you're writing. Let's start with sine first. If this is half of a graph, I can kind of makeshift the rest of it. Where's my midline? It's 0. So if my midline is 0, which letter is going to be 0? D. We're writing a sine first, and then we're going to write a cosine. And technically, like I said before, A, B, and D are all the same for sine or cosine, so I really could fill in both of them at the same time. What's my amplitude? It's going to be 3. Remember, it's the distance from the midline to a max or a min. Now, one thing I will say about this. For sine, doesn't sine cross the y-axis of 0, 0 and then go up? But this one goes down. What would cause that? Over the x-axis. So that means, is the negative going to be on the outside or on the inside? Outside. We'll get to that one. What's my period? Period. What's my period? Not B. What's my period? It would be 4 pi. Because if half the period is 2 pi, then the full period would be 4 pi. Here we look. You do these enough times, you'll start to catch on to them pretty quickly. Yes. Since we had half of the period going from 0 to 2 pi, that means we would double it to get the full period. Is there a phase shift? Not for sine. So there's your equation. If you want to clean it up, you can. It's going to be a negative 3 sine 1/2 x. For cosine, A, B, and D are all the same. So B is 1/2. A is still 3. And would it be a negative? Well, to make it easier on ourselves, think about it. Doesn't cosine normally start at the maximum? But if sine got flipped over, couldn't cosine also get flipped over? And wouldn't this essentially have been a maximum had it not been flipped over? Think about it. It would have been up here. What would cause it to flip over would be down here. So if we did make a negative, we would essentially be talking about this as our maximum. Now, you don't have to do that, but your phase shift is going to be different depending. y-axis. And this is why. If this should have been our maximum, how far is it away from the y-axis? Pi. And did I move to the left or did I move to the right? So I moved to the right. So my phase shift is pi. Solve for C. What's B? 1/2. Solve this out. Solve for C. However you solve something like this. Find C. Okay, can we all agree it's pi over 2?
Yes.
Okay, it's all pi over 2. Now the thing is, we moved to the right, which means that it has to be a what? It's going to have to be a negative. So when you guys told me that our phase shift was a negative pi, if we move to the right, shouldn't that be a positive? When we move to the right, it's a positive, isn't it? So our phase shift was a positive pi. C is going to have to